Oh, hey there! So you think you know promises, huh? In JavaScript, promises are both a way to handle asynchronous operation and a data structure. Whether you are making a HTTP request, querying a database, or writing to the console, I/O operation can be very slow. Because JavaScript is single-threaded by design, can only do one thing at a time, asynchronous or async operation are very common. Let me give you an example. Say that when a user of a web app clicks on a button that triggers a HTTP request, the JavaScript runtime had to wait for the request to resolve before handling any other operation. It would make for a pretty sluggish experience. Instead, the engine makes a request, put it aside, and get ready to handle any other operation. Every now and then, the process will look at the request and be like, "Are you done yet?" When the request finally resolved, the engine will execute a function defined by the developer to handle the response. You might know those as callback function. A good example of this is setTimeout. It's a function that takes another function as argument, which will be executed later asynchronously. Callbacks work just fine in many cases, but start becoming especially difficult to deal with when multiple interdependent async operations are needed. Say we have a function called retrieveCurrentUser that takes a callback function, which the first argument is an error that is set if something goes wrong. The second argument is a user, which is set if everything goes right. In this case, we'd have to test the error and handle it if it is set. Then we can go on and do whatever we need to do with our user. In this example, I'll set the user status to be given its ID, active, and then finally we have a callback that has an error if something goes wrong. Now we might want to check that error and handle it if it exists. Next, let's say we need to retrieve active threads for the user. So we could say user ID, we need the user ID, a limit, how many threads we'd like, and another callback function that takes an error if something goes bad, and the threads if everything is right. All right, so now we have all of our threads for our user. We also need to test if there's an error and handle it accordingly. Okay, good. And now for all of our threads, we want to subscribe to them. See if there's a new message when they come in, we want to be told about it. So this needs a thread ID and the user ID and a callback function, which we're going to handle if it exists. Whew, that was something. If you are subscribed to this channel, I love you. So let's talk about promises. I've mentioned earlier that a promise is both a data structure and a way to deal with async operation. Here's what I meant by that. Imagine you have the number 42 that you assign to the variable x. From this point on, x refers to the number 42 and you can treat it as such. Now take a function called f that simply multiplies by 2 any number. If we were to pass x to the function f, it would produce a new number, 84, that we can assign to the variable y. From then on, y is 84. A promise represents a value that may or may not exist yet. If we assign p as the promise of 42, you can also say that p refers to the number 42 and use it as such. The difference is that because p may or may not be 42 just yet, remember, async operation, the value 42 can't be accessed directly. We use the then method to access and transform the value. Similar to our previous example, if we have a function f that multiplies any number by 2 and we apply it to our promise p, it would produce a new promise of the value 84, which we can assign to the variable q. From then on, q is a promise of the number 84. It is important to note that p is still a promise of 42. So now, what if we had a function called g that takes a number, multiply it by 2, but return a promise of the result? After we apply the function g to our promise p, which is still 42, we still end up with a promise of 84. The rule is that if a function returns a value that is not a promise, the value will be wrapped into a new promise. But if the value is already a promise, we don't need to wrap it again. A promise represents a value that may or may not exist yet, but it also represents the status of the async operation. A promise can either be resolved or rejected. The then method actually accepts two functions as argument. The first one for the happy path if the operation has resolved. The second one to handle any error that may have occurred. Because promises are often chained together, there is also a catch method that accepts a function to handle the first error that occurs, breaking the chain. A rejected promise that has been caught always returns a resolved promise. Let's go back to our previous example with multiple interdependent async operations. So the first step is for us to get our user, which we can store in our user variable here. And the next would be to get the threads. And to get the threads, we need the user. And so first, while we have the user, we can set the status of the user to active. And then retrieve all the active threads for the user. Like that. So this first variable will be our user, our promise of a user. And the second variable will be our promise for our threads. And whenever we have both of them together, meaning they are both resolved, we can go and maybe we can subscribe to all the threads, make sure we get the notifications. This is quite annoying. And now we can catch any of the error once. And then we can catch any of the error once. That's really nice. And from then on, the user promise and the threads promise still represents the initial value it can be used without any unnecessary nesting. For example, we can say, now we have our threads. Then we can use it to maybe generate some components. For each of them, we'll give them the object and add them to our body. Well, you might have noticed that you can factorize a resolve promise with the promise resolve function. You can deduct that there is also a promise reject function. These functions are useful when you need a quick way to create a promise. But if you want to create a promise from an async operation, you will need a promise constructor. Let's create a function called wait that takes a value for the duration of the wait that returns a new promise. The promise constructor takes a callback function, and the first argument of that function is the resolve function to call whenever something has resolved. And here we're going to use it as part of setTimeout, which we're going to give the duration to. Now we can use it like this, where we say wait 1 second. Then we can do something. Like this. The promise constructor function also passes a reject function as a second argument. To demonstrate the reject function, let's have a situation that at random will throw a promise, and that's just for the sake of an example. So we're going to reject with an error. And otherwise, we'll resolve in 1 second. Now our code will either alert us that we've waited a second or show us a sad face. A promise is a data structure that represents any type of value which may or may not exist yet. The promise protects the value from being accessed directly. A handler function can be defined to access and transform the value. When the handler function returns a value, it creates a new promise for this value. In modern JavaScript, understanding and mastering promises is a very important skill. They look a lot scarier than they are. I promise they're your friend. I hope this video was useful to you. If you learned something, please like, share, and subscribe. It might sound cliché, but it helps.